Okay, we've been asked to find some points on this curve where the gradient of the function is 0. So what we're going to have to do first is we're going to have to take the derivative of the function. Now the derivative here is going to be a little bit tricky because we're going to be using the product rule because we have two sort of individual functions. But when we come to differentiating the back part, we're going to have to use the chain rule because of the fact we've got this outside function and an inside function. So let's have a go at that. So we've got dfx dx. Now this is going to be equal to, we take the derivative of the front function, this is the product rule, which is just 2. We multiply it by the back function, which is going to be 2x take 5 all cubed. Now we're going to add that to the derivative of the back function times the front function. Now what we'll do, to make it easy to understand, we'll do the derivative of this back function separately to start with. So we're going to use the chain rule where you've got u of x is equal to 2x minus 5 and f of u is equal to u cubed. So the derivative, like df dx, will be equal to df du times by du dx. Now this is just the rule for the rule or the formula that governs the chain rule. So just using that, df du is going to be 3u squared, and we're going to multiply that by du dx, which is just going to be 2. So that's equal to 6u squared. Sorry about my handwriting. And if we replace u with the function, we have 6 2x minus 5 all squared. So we've got the derivative of the front function times the back function, and we have to add that to, this is the product rule, the derivative of the back function, which we just, using the chain rule, solved out to be this. Two x minus 5 all squared times the front function being, we leave it alone, we don't do anything. So we just go 2x minus 1. Cool. Now that's our gradient function. Now what we can do is we can do a little bit of rearranging to make it easier to find where the gradient of this is going to be equal to 0. So what we're going to do is we're going to take out a common factor, which is going to be 2x minus 5 all squared. So that's what we're going to take outside a bracket. The reason we're doing this will become obvious in a second. So that's the common factor, 2x minus 5 squared. Now we have to multiply that from the front one, 2 times one more lot of 2x minus 5 to make 2x minus 5 cubed. and we have to multiply it on the back. 2x minus 5 squared, so we only have to multiply it by the 6 and the 2x minus 1. Great. Now, what we're going to do next is we're going to simplify the inside part of this. So we're going to multiply out our brackets and we're going to collect our like terms. So we'll just quickly write the front bit down again. Now inside the bracket we're going to have 2 times 2x, which is 4x. 2 times negative 5, which is negative 10. 6 times 2x is 12x. Six times negative 1 is negative 6. Now, combining our like, now I'm doing this like I'm putting together every single step to make it easier to follow if you don't quite understand what you're doing. But in an exam style situation, you wouldn't necessarily do all of this working out. So you'd be able to probably go from here straight to where we are now. So what we then do is we're going to be combining our like terms in the bracket. So 4x plus 12x is 16x. That bracket's a bit great. Let's get rid of that. Let's put a better bracket in. 4x plus 12x is 16x. Negative 10 minus 6 is negative 16. Okay, now that is our simplified. This is just this, but we've just simplified it. Now, the gradient, we have to find the points on this curve, where the gradient function is equal to 0. So we're going to make that equal to 0. Now, using the null factor law, so we'll just write that down. So by null, sorry about my handwriting. So by the null factor law, and what the null factor law states is if you've got 2 or 3 numbers which are being multiplied together and they equal 0, at least one of them has to be 0. So in this case, either 2x minus 5 will have to equal 0, or 16x minus 16 will have to equal 0. So we'll start with the 2x minus 5. And we can just do a quick bit of algebra to find that x here is going to be equal to 5 over 2. We're going to do 16x minus 16 has to equal 0. So in this case, take the 16 over, divide by 16, x will have to equal 1. Okay, great. Now we have our 2 x points on our curve where the gradient is going to be equal to 0. Now we just have to find our y values. So the easiest way to do this, or the only way to really do this, is to get our x coordinates of the points where the gradient is 0, and then substitute them back into the original function up the top. I'll just quickly change color. That color you won't be able to see. Hang on. Yeah, we'll go black. So start with the 5 on 2. That's going to be probably the more difficult one. So we're going to have f of 5 over 2 is equal to, now again I'm just writing all of these steps out longhand. If you feel comfortable with doing these simple fraction multiplications in your head, you would not have to write this down. So 2 times 5 over 2, because I'm substituting 5 over 2 in for the x value, minus 1, and then we're multiplying that by 2 times 5 over 2 minus 5 all cubed. Okay, so 2 times 5 over 2, the 2's will cancel and it'll just be equal to 5 minus 1, which is 4. And we're multiplying that by 2 times 5 over 2, which is 5, minus 5 is 0. Cubed is still 0. Cool. So we got 4 multiplied by 0 is 0. So the first coordinate point is going to be 5 over 2, or 2.5, comma, 0. Okay, and our next coordinate point, we've got x equals 1. So we have f at 1. So what we have here is we go 2 times 1 minus 1 multiplied by 2 times 1 minus 5 all cubed. Great. So here we have, this is going to be equal to 2 times 1 is 2, minus 1 is just 1. 2 times 1 is 2, subtract 5 is negative 3, and negative 3 all squared is negative 27. All cubed, sorry, is negative 27. And 1 times negative 27 is negative 27. So our second point then is 1, comma, negative 27. So this point and this point are points on the original function where the gradient is equal to 0.